Welcome friends to my channel. Now yesterday's lecture I have discussed about geostationary satellite, and there I saw that a geostationary satellite must be placed at a height almost 36,000 kilometer from Earth's surface so that it can work properly. Okay. Now in our today's lecture I shall going to discuss the energy of a satellite. Okay. So our topic is the energy of an artificial satellite. Okay, energy of an artificial satellite. So we know that suppose this is Earth and a satellite revolves around the Earth. Okay, so this is obviously the radius r. Okay, and if the satellite is located at a height h, then we always know r plus h we call small r. So if the satellite of mass m revolves around the earth say with the orbital velocity v, then we all know that what would be the kinetic energy of the satellite if its mass is m and its velocity is v. So this is the orbital velocity, and again we know from previous calculations that the velocity of an artificial satellite is this g into m by r, where m is the mass of earth, capital M is the mass of earth. So from which we can easily conclude v square, that is simply gm by r. So substitute this value, so what we get, g into m upon 2r. Okay, so this is the kinetic energy of an artificial satellite revolving around the earth with a velocity say v. Okay, now what would be the potential energy of the satellite? Now we all know that potential energy is nothing but the amount of work done in taking an object from infinity to any point at the surface of earth. Okay, so potential energy means v, work done in taking the satellite from infinity to any point on earth's surface. Okay, so this we can write, so infinity to r, force multiplied by distance. And what is force? Force between the earth and the satellite is g into m by r square into distance. Okay, so this is the potential energy. So let us simplify this. So gmm, so this is simply r to the power minus 1. Okay, infinity to r, that means simply minus gmm by r. So this is the potential energy of the satellite. Okay, simple. Work done in taking the satellite from infinity to any point in the surface. Now we have in our hand the kinetic energy and the potential energy. So if we add these two, then we will get the total energy of the satellite. So total energy of the satellite E, this is equals to T plus V. Okay, so what will be my T? That is gmm by 2r minus gmm by r. So this is simply minus g into m by 2r. Thus we see that the total energy of the satellite is negative, and there is a significance of this negative sign. Okay, what is it? Now let's see. we all know that due to the collision with the atmosphere, the total energy of the satellite always decreases, that we know. So this term entirely decreases. So if minus gmm by 2r decreases, then gmm by 2r increases. So gmm by 2r increases. Okay. So if gmm by 2r increases, that means r decreases. And if r decreases, h always decreases. So the satellite comes closer to earth's surface. Okay, so the negative sign in front of it has a significant value, and we all know it. Okay, so what is the significance that I am going to write here? It's very important. Due to the collision with atmosphere, total energy E decreases, that is minus gmm by 2r decreases. So minus gmm by 2r decreases means gmm by 2r increases. So gmm by 2r increases, and hence r decreases. As a result, height decreases. So the satellite come closer to earth surface. Okay, so this is the significance of it. Okay, so this is what about due to the pollution with the atmosphere, there is energy loss, and due to which the satellite comes closer to earth surface. Okay, so this is what about the energy of an artificial satellite. Now let us do a simple numerical related to artificial satellite, so that the problem concept will be clear. Now the problem is that we have to find out, when a satellite revolves around the earth, angular momentum increases the velocity of the satellite. Okay, for an artificial satellite, revolving round the earth, show that, this is also a conceptual question. Okay, show that L and increases the velocity. That means we have to show that the velocity of the satellite increases. Okay, that is due angular momentum increases the velocity. Okay, or you can say, show that the it increases the velocity. That means we have to show that for a satellite revolving around the earth, its velocity always increases. Okay, so how we can prove it? So this is the r, and this is the height of the satellite. Say this is of mass m. So we know the orbital stability condition, that is, if the mass of the satellite is m and its orbital velocity is v, so mv square by r, this always balances the gravitational force of attraction. Okay, so r cancels. Okay, so here we get mv square r, this equals to gmm. Now we have to find out that angular momentum, due to the presence of angular momentum, velocity increases. So we have to bring here the angular momentum. So how? mv square r, that means mvr into v. We cannot cancel because if we cancel this and m, then we cannot introduce angular momentum. Okay, so we can write mv square r as mvr into v. So this is simply gmm. Now you can put mvr in l instead of mvr. So lv, this is simply gmm. So what will be my v? My v will be gmm upon l. Now if you consider linear motion, then frictional forces in linear motion always create an obstacle towards its motion. That means frictional forces reduces the linear momentum in linear motion. Similarly, if we took the air friction here, if the satellite is rotating around the earth, there must be a air friction. Okay, so air friction obviously reduces the angular momentum. Just think of it, that if air friction or air damping reduces the linear momentum in linear motion, then air friction will also reduces the corresponding angular momentum in rotational motion. Okay, so air friction here, air friction, not L. Okay, air friction reduces the angular momentum. Air friction reduces the angular momentum. So if angular momentum is decreases, then V increases. So this is the answer we require. Okay, main thing is that this. So due to the presence of air friction, angular momentum decreases, as a result velocity v increases. So this is simply a numerical problem. Okay, so today's lecture is short. In our next class I shall going to discuss about the escape velocity. Okay, so dear guys, if you don't subscribe my channel, then kindly subscribe it to get latest videos on physics. Okay, thank you.